This is the program to find out the prime number, whether the entered value is prime number or not. Okay, let's get started. Here, include stdio.h. This is the header file. Include stdbool. This is a boolean header file. If you are using the boolean keyword, then you have to include this header file. Bool return type. We have a return type that is bool. Bool means what? Bool means either it is true or false, right? So is prime, this is the function name. Int n, this is the parameter. For now, we have just one parameter. Here, this is the entry point of the program. Whenever the is prime function is called, only after that control came over here. But here, let's see the function first. So is prime is a function. We are taking int n as an integer variable or the parameter. Here we are checking if n is less than or equal to 1. Why? Because we are trying to find the prime number. Prime number means it is either divided by 1 or itself. So n is less than or equal to 1. Is 1 a prime number? No. And is 0 a prime number or negative value? We are not checking that. So the positive number that is greater than 1 will be only considered. So whenever the entered value is either 0 or 1, then we are simply rejecting it and telling it to return false. Okay, until now, if 0 and 1 is entered from the user, it will return false. You do not have to understand anything. Boolean format, false is written when n is less than or equal to 1. N is less than or equal to 1 means 0 or the negative values. After that, here, if the entered value is not 0 and 1, instead it is positive number, what happen is it will go to this part. This is a for loop statement. If you don't know about for loop, please check the I button over here. I will provide the link for the statement part, or you can check the description over here. Okay, so now here you can see for loop int I equals to 2. As we know, 1 is already returning the false, so it will start from 2 and n by 2. Why n by 2? Because prime numbers, right? So if the entered value is 8, 8 will be divided until 4, right? 4, 2, 4 2 is 8. So here you can see 2 is divided. Now what happened 8 divided by 5? The value will decrease in the decimal format, right? So there is no point in checking after the value of half of the value. There is no point in checking any number. You can guess like 32. Here you can see 32 is divided by 2. That is half of it, like 16, right? So if 32 will be divided after 16, that is 17, then the value decrease again. Are you getting it? Here you can see the value 32 divided by 2, 16. Well done. But 32 divided by 16 after 17, it is 1.88. Whatever the value you enter after that, 18, it will be decimal. 19 also decimal, right? So 32 will get 1, but 30 a decimal value, a decimal value. Whatever the value we enter will all be in the decimal format. So there is no point on checking after the half of it. So we are going until half of the entered value, right? So I is less than or equal to half of it. If 16 is entered, we will only check till 8. Yes, we can check to n value, but what we are doing is we are making it short to process fast. So we are going up to 8 because we know going to that number will not give any sense, right? So I plus plus every time we are increasing it. So n% equal to 0, then return false. Now what does this means? n%i equal to 0 means it will give the reminder. If n, that is entered number 16, is divided by 2, then it will just give 8. There is no reminder. Reminder is 0. And if reminder is 0, we should return false because it is not a prime number, isn't it? But what happened if the prime number will be entered from the user? Like 17 is a prime number, as we know, right? So when 17 is entered, then what happened here? I, that is 2. If 17% 2 is equals to 0, no, because this will have some reminder and that condition is false and it will go to return true. You are getting it, right? So why we are checking until n by 2? You are clear about it? Until this loop is over, it will check for every value. if any of the value that is like n% I equal to 0, if it came, then it will directly return the false value. If it doesn't came, then it will return true. You are getting it, right? So whenever the condition is fulfilled, that is n% I equals to 0, it could be in 2, it could be in 5 or anything. If it is divided, then it will return false, right? So if it is not, then it will return true value. Now let's come to the main program. Int num scanf, right? Printf enter number, scanf number. Now this is asking a user a number that will be entered from the user, and it is stored inside num variable. Now what we are doing is prime. If here, this is the condition, right? If is prime num, in is prime function we are passing num variable, that is a parameter. Then it will go over here, is prime, then it will get a number. Now number, what it is returning, either it is returning a true value or a false value, right? Or a false value. Now here it is checked if is prime num. Now if will take either true or false, right? True or false. So whenever the true value is received, then what it will do, the if part. This is like the prime number. This will print num is a prime number. And if the false is returned, like if a false is written, then it is not a prime number. So you got it, right? Whenever it is divided and have no reminder, then it will return false. If it will check to until n by 2, and if it doesn't get any such reminder is 0 or not been divided by any of the number from 2 to n by 2, then it will return true. So this is the complete logic behind the prime number, and whenever it is called, it is going to transfer the control and do its task. So this is how the prime number works in C programming. So what will be the output? You will enter one number. It will be either the prime number or not a prime number, and it will be printed. So this is all for how the function works and how the prime number is determined using C programming. We will discuss more in our next video about the function. This is all for today. Thank you. Do not forget to subscribe.